stop assuming that you're going to make a flowchart proof, and they will start giving you the option of flowchart or two column. So, two column proofs, as we all pretty much know already, are better. Well, at least in our opinion. So on your paper, I went ahead and put this, though, one last time. Let's do a flowchart proof. So take a minute. Now, hold on. Here's the difficult part of this situation. Yesterday, what we were seeing when we were working with those rhombuses is congruent triangles, right? Either two congruent triangles or four congruent triangles. And Ansel is actually tired of using congruent triangles, right? He's like, no more congruent triangles, I'm over it. So Ansel wants to prove that A and C are congruent angles, but doesn't want to use congruent triangles. I need you guys to reason through and fill in this this flowchart proof, so then we can talk about how it would be as a two column and why two column is quote unquote better.
So like parallel lines.
Chat with each other.
So just make a bunch of transversals.
Yeah.
So remember, outside the circle goes the reasoning. So definition of a parallelogram, what you should be thinking is, what statement would have gone in here that is part of defining a parallelogram that leads to B being equal to C?
So we
and what don't we see up there yet? You might want to grab a couple highlighters for today too. That might be helpful.
Okay.
Sorry, I should have thought about this sooner. TUWV, right? So WVTU. And that would actually also come from definition of a parallelogram, right? Because the opposite sides are parallel. That had a weird inflection, sorry. I was debating what to do with that awkward inflection.
What's that line?
This TU parallel WV.
Yeah,
It is. It's slash slash. It's there.
Oh, there.
So what should we highlight exactly?
Oh, the other lines. So what Sophia's hypothesizing was these haven't been talked about yet as part of our parallelogram. So right here would go WT parallel UV.
Should we highlight what you highlight?
That's up to you. Whatever works for your brain. Now wait, what? So what goes at the start of every proof we do? The given. What is given in this situation? WTUV is a parallelogram.
I forgot I have to write teeny tiny for these.
On the back, I leave your space kind of just very open. So wait, what reason are we going to put on angle B being congruent to angle C?
They're corresponding angles.
Ooh, corresponding angles. Because we got the parallel lines, and this is... I didn't want that to be blue, but okay. This is outside the circle, quote unquote, corresponding angles congruent. So my yellow sides, oh come on.
You could say that A and B.
And then A
Now
and
with
B
this, you say A
are
and B is
equal
equal
because
to
they're opposite.
interior angle.
Imagine, and actually extend on your paper if you want to, if all of these lines go further than they actually do. Right, now it's easier, and they kind of started extending that top line, but now it's easier to recognize angle A is congruent to angle B, and they already gave us the reasoning. Alternate interior angles. So A and B are our alternate interior angles. Now, technically, we don't have the lines out there till we extend them, but we can still kind of make that claim because we know that. Are you just trying to turn something in?
Oh, sorry.
No, what do you need? Elena. The math that happens in this class is very slow and very thoughtful. You are not really.
Sorry, I thought you.
You can use it here or you can take it somewhere else.
The mouth of the
Hey, sometimes you want to kind of push it left as you use it, so don't just drop it straight down. You have a little pressure stop. So then we have angle B or angle A equal to angle B.
Highlighter colors.
Oh, but I can make any. Oh, you're gonna run out of highlighter color.
Yeah.
Yeah, you are correct.
I'll just have to make purple with pink and
Can
blue.
we just say angle A or can we just say
Because A and B are specific angles, that's okay. But if we were talking about the uppercase letters that are the vertices, we would need to actually use 3-point angle notation. Because you couldn't just say angle V. So if we didn't have A and B here, we would say angle WVU.
Could you like give them a label?
Angle symbol.
Sure, if you're able to, but like on a standardized test, you can't really like add something to a thing that's in the computer.
I know, but like.
Now you could say allow WVU to be A and VU. There's no point out here. That becomes problematic.
Yeah, I'm talking about if you can.
So
do it.
if A is equal to B and B is equal to C, then A must be equal to C. Now, people like to confuse substitution and the transitive property. Can anyone tell me the difference between a straight up substitution equating that if A is equal to B and B is equal to C, that A is equal to C, as opposed to what transitive property would mean? We're not using this right now, and I don't know when the last time we did use it was, but I want to review it just because it is.
Use the transitive property.
Transitive, and you're all just going to be like, oh, well, of course, is not when they're equal, but when they're unequal. So if A was greater than B, and B was greater than C,
then A would be greater than C.
then A must be greater than C. That's transitive. Does that make sense? Because it's like translating this relationship through that relationship creates this other relationship. All right, gotta love math language.
Oh boy.
So now let's clean this up and two column it. So you have this on your paper because I'm nice and I decided to actually give you a handout today.
Oh yeah, thank you for doing that.
You're welcome. So normally if you're doing something for me, the top's here, and you might want to make a little note so you remember that. Really just need an S and an R. We never, ever, ever, ever flip those around. S is always on the left. Because the reason is what is justifying the statement we just made as being true. So we say something, then we back it up. Then we say something else, and we back it up. Once we say something up here, we are able to use it as an assumption down here. So the statement in step 2 can be used as an assumption later on in the proof. Does that make sense? Because we've given a fact of why it's true. You might want those. So if TUVW is a parallelogram, that's given. Definition of a parallelogram. And here actually is where we can do two-column proofs even more efficiently. When we were on the flow chart, we said, I forget what the points were. They gave us TUWV, and we said WT and UV. So WT and UV. However, we could also, in the same step, say TU parallel to WV. Because both of those things are part of definition of a parallelogram. So either you could grab this and put it up here, or, here's the cool thing about two-column proofs, the double tick, the ditto mark. You can use the ditto mark in your two-column proofs. So if you are spreading things out and you're stating one thing after the next thing after the next thing, and you do just, like you stop right here, and you do just WT parallel to UV, obviously that's because definition of parallelogram. Now we can say TUWB. Oh crap, we realize we're using the same thing. We just use ditto instead of writing it out.
Oh, that's it. Oh.
Seriously, that's what we do. So then they say B is equal to C, and we said from our flow chart, which you guys can still see easily, why was that? Corresponding. Something to the effect of corresponding angles from parallel lines. Make sure you're just getting done what you got to get done, because I could see you just kind of doing this math class. Logan would be the 7th grader that would sit down and want to do this math with us.
Oh my god.
And I would have to chase him out of here, yelling and screaming.
Okay.
Wait, it's in 7th grade.
Yes. So then here, what went in our statement box? For if lines are parallel, then the alternate interior angles are congruent. A equals B, right? Because B was that exterior and A was that interior at the bottom. And then, since A equals B and B equals C, A must equal C. Any preguntas?
No.
Questions? Come on, you're in Spanish.
I
No,
know.
it's not.
You ditched it.
I did.
Alright, try this on your own. Proving that a perpendicular bisector will create two congruent triangles. So what you are trying to do is get to the statement that they want us to prove, which they tell us up here PA is congruent to PB. So we should be able to fill in only in this amount of steps or less that gets us to PA equaling PB.
Okay, but
You cannot use any assumptions. You have to write things out and talk about why.
so like.
And this,
Work
you could write
together?
over here. Yeah. Well, except without me. Write yourself a reminder that that's CPCTC, because you're probably not going to draw the
Why
pictures.
does that sound like a lie?
Sounds like hepatitis.
I'm going to name my firstborn child CPCTC.
What?
I have
Sorry,
no. Oh my gosh, are you
Don't-
sick? Yeah, I'm
Don't do that. Don't. That just.
You have less than 5 minutes.
They'd be confused, but when they got older, they'd hate you. You have been diagnosed with We have diagnosed angle P.
Um.
Alright, let's do this.
It's just given.
So,
Is this a secret?
oh, that, okay, yeah, we can say there's a right
Definition of
angle.
perpendicular.
Oh no, angle AM is congruent to BM for the bisector. Yeah, on the side. Why is that?
The definition of the perpendicular.
The reason I gave you the handout was so you could draw on it. And so that your bisector would actually bisect. Instead of if we draw it, it probably won't be perfect.
Yeah.
So that's why I gave you a handout. Please use it. Please mark it up. Highlight it. Indicate parallel. Indicate perpendicular. Indicate congruent. I'll stop talking.
I tried little dashed lines to show
I see.
Wait.
Like 90-degree angles.
Should we work together or just no? No. That's fine. Yeah. It's like
I think I'm doing this right. I don't know. Oh, look at that.
Not really a hint. You should already be here. I should be behind you.
Already, but like a hen. I wrote never mind. Okay, so we know this is we're trying to prove that PA is equal to PB.
I don't know how to state this.
I need to go after.
Well, wouldn't
Oh,
I feel like I
property,
just
guys.
skipped too many though.
Yeah. Yeah, PM is shared. PM equals PM.
Oh, rough left
Yes,
strip.
but then
Okay.
it says definition of perpendicular, and I don't know how to state it. I know what to do, but just write it. Yes. Say I feel like say this angle is congruent to this angle. PMA is congruent to PMB.
So we
Or that.
know. So So now that we have these three things, we can say that like PAM is equal to BDM.
Because we do know that two congruent lines, or sorry, two perpendicular lines make 90-degree angles. So you could either just say AMP is congruent to BMP, or we could say that they're not only equal, but they also equal 90 degrees because perpendicular tells us that. Which this would later let us say right triangle, right? If we throw in that there's a right angle, as opposed to just congruent angles, which it's true, but sometimes we have congruent angles that aren't right, right? So it's worth writing in the equals 90. It will save you later, potentially. Maybe not on this proof, but maybe on the next one. What goes in for definition of a bisector? AM is congruent
I got it. I'm done.
to BM.
What? Oh, I wrote MD.
No, it's the same order.
And then it's PM is congruent to PM side.
Oh, PM is congruent to itself. What property do we use for that?
Reflexive property.
And then
And then
Triangle PAM
and then
then we
side angle
triangle
side.
PBM.
Ooh, triangle what?
PAM is congruent to triangle PBM. Okay, I have a little bit more.
Why?
Because it's
Side angle side, right?
SAS.
Now, to use any of these triangle congruent statements, you have to check, did we claim a side, an angle, and a side in our proof? It doesn't matter if we know it, we have to have it up here. Does that make sense? I know I am probably feeling very redundant to you, but this is what I end up marking wrong. And like the notes I normally write on tests is how do we know? How can we how can we say this? Like you just have to write it out. It doesn't matter if I know it and you know it. You have to write it out. Questions? Flip to the back for more two-column proof
When you
fun.
get ASS congruency, you know something's wrong.
Oh wait, this one.
This is especially why I gave you a handout, because I didn't want you guys to have to try to draw this. So what we know is with pair of triangles, and then just what they tell us. So A, I was expecting you to use the upper kind of on the left statement reason area, and you probably don't need that much space, and then B will drop down here. So if you write wider, then I was gonna split the page, but then I realized like, oh, it's probably just as easy to do that.
Could have just put it like sideways.
I was going to, but you can't turn one of the pages and have the whole document changes orientation, at least I think.
If
Or I'm not
C is
good
the
enough.
midpoint of BD, then the line AEB, the
I'm gonna challenge you guys to try to get both of these done in 5 minutes.
No.
They share the vertical angles.
Are we working
ACB.
together?
Yes.
I think you should.
Wait, no, we should do some givens.
Ooh,
Okay.
always start with given.
One given is C is the midpoint of BD.
We also know that the
So
parallel
AB
lines
is
is like
parallel to
Yeah.
the other
AB.
Normally, once you write down one thing, there's a trickle effect.
Oh,
now we should.
It's ED. No
No
need.
need.
Because the alternate theory.
What are we trying to do?
You're trying to prove the triangles are congruent.
Okay.
It's DE. No, it's not. It's ED.
Donnie, where are y'all? Like, who?
Yeah, okay.
Where?
And then angle A is congruent to angle E by alternate.
AB is
And then same with B and D.
which B and D?
Are congruent.
What?
Oh, A and D.
What do these do for us?
They're parallel.
So they give us a given, right?
Yeah,
Yeah,
that's
So
why
the
we
fact
said
that those
AB
lines are
is
parallel,
to ED.
the reason's just given.
Oh shoot, I didn't put the midpoint. I didn't write down.
We want to define what the midpoint
I don't
does.
wanna erase it.
The midpoint is the middle.
So DC is congruent to.
Oh wait, that's the midpoint. It proves that whatever.
EC is congruent to DC.
Alright, then we have angle
Because do we write definition of bisector?
I don't know. I'm just doing
Definition of
stuff up
Say
here.
midpoint.
Talk to each other.
definition of midpoint.
Wait, what would be a reason for BC is
Definition of midpoint.
okay?
And then it's
Wait, what?
congruent by angle side. Triangle.
Oh, AC and C.
Well,
we
they-
already know C.
How did
Doesn't it?
C is the
Doesn't it
bisector,
state
and
that
if this is the
C
bisector,
is the
then these two are
midpoint
equal
of
to each other.
BD?
No, we're trying to prove that C is the midpoint of BD.
It does
Okay,
that.
but it
No,
says
we're
it right
trying
here.
to prove that your
What are
triangles
we
are
trying?
congruent.
We're trying to prove
So
that
then
it's
it
congruent.
states that.
I got it.
That was
Right.
that was given.
Okay.
This
That
is
was
given.
I was confused.
I said write that first. Write that as
Wait,
given.
we can say that angle ACB is congruent to angle EDC because
Yes.
of vertical
Yeah, I
angles.
finished. So you guys need anything?
Way to
That-
sound cocky. I finished, so
Yeah.
if you guys need anything, you know.
That was.
I didn't wait and work with you. I didn't operate like a team. I just left
went.
you behind.
I just went.
Well, I'm gonna take like 5 minutes. To
Not
make
much
the
of a
chart.
Jedi there, are you, Leanna?
I don't start with what?
Don't leave anybody behind.
And that's untrue. I think.
What do the parallel lines do for us?
Give us another angle.
Ooh, give us another angle.
Wait, are we now on to B, or are we still
No.
doing?
Still.
Okay, I'm just gonna go on to B.
Wait, if each of these triangles has a blue angle and a purple angle,
We can just do angle, angle, angle.
oh, we could just actually extend the other transversal and do another alternate interior, couldn't we?
We could just
But
do
because
angle,
this
angle,
drawing's
angle.
already really messy, I might as well make it even messier.
Wait, can we say
It's already proved though.
Well, I know, but either way, you. So here's one of the fun
wants to
things
make a
about two
bigger
column.
mess.
Hold up, this is actually really good that we're talking about this. This is one of the fun things about two column proofs. How you get there may not be the same way I get there. Because I could show that angle BAC and CED are congruent based off alternate interior, or our reason could be triangle angle sum.
Couldn't I just say like angle E or something?
We can already prove triangle congruence without stating that the orange angles are congruent.
it's
I'm doing it.
side angle
Well,
angles are
then
congruent.
couldn't I just say like B or D for the angles, or is that?
You could. C's the only one you can't really. But we still like using 3-point notation
don't
because
know.
we sometimes
Okay.
use the exterior angles. Sophia, so that's the danger is if we
I
use an
got
exterior
side
angle.
angle congruency.
Is that the right order of what you found?
Yeah, I thought of
I
is it
said
angle
side
Angle, side angle.
How do you know two sides?
No, it's angle
I
and
said
side.
side angle.
Oh, what two angles are you talking about?
The
The vertical
angle
angles
and the alternate interior angle. And
of like what I have up there as purple?
as orange.
Oh. Well, is angle side angle a usable congruence proof?
Yes.
Really, I think what you have to stop asking is side angle angle and do angle angle side. Do you remember AAS? ASS we cannot use, but can we use AAS?
Yeah.
Yeah, because remember AAS is the same thing as ASA. Because once we have two A's, we have three A's.
Oh,
But AA is a similarity thing.
Exactly, so we just need
oh,
an
then
S.
Okay, so
Any S being
so
involved
does
with two
SAA
angles.
equal to
Yeah.
AAS? Okay, well.
Because think about it, those two A's, you have all three A's.
Okay.
So you can use whatever
It's
order you
not
want.
angle
I
side side.
We
prefer.
have that, so we need to find.
I
Then we
prefer
have K.
talking about angle side angle. Nice little relationship there. Because hey, let's review something real quick. Give me your attention real fast before you go on to B. I know I challenged you, but we're already at 5 minutes.
I've already started.
That's fine. Angle side angle works, just to review this, because the hinge theorem then dictates that because this side is coming off at this angle, and this side is coming off at this angle, there is only one point where they will intersect with each other. Same thing over here. So that and that will only have one intersection point up here, which means those triangles must be congruent to each other.
Cell diagrams.
Careful, Simon, if those rings pop open, it's a dangerous way to pick up your binder.
Just that picture.
That's
Colorful
me in
and
a
a little.
nutshell.
The white is the side of
Colorful and a little.
Confusing.
Yeah.
in it once.
So, KH is
The
PM
second one's
because
very easy. It's just angle.
oh, side, because of
No.
Pythagorean theorem.
I'm not really
Darn.
listening.
Okay. Well.
Sorry.
That's what went
Don't.
wrong, wasn't it? Okay.
Are we?
Well, when we don't we just
What
No,
are we
so
trying to prove in this one?
That the two triangles are congruent.
Okay,
well
so I
wait.
thought I got it, but it turns
Pythagorean
out I was wrong.
theorem.
Yeah, we
Side,
got
side,
it.
side.
Darn. We just have to
So
figure
many
out
spaces
PN
when I'm
side,
using
right?
them.
And yeah, you have the Pythagorean theorem.
So MP squared plus PN squared equals MN squared something. Wait a
At the
minute.
end of this, we're gonna have a new tool in our toolbox that you might remember using or might not. What if
RHL.
What?
Oh
Oh,
yeah, RHL.
Right,
I also got
RHL
it,
congruency.
Thanks for letting the cat out of the bag.
Which one?
If I put
What was the-
G up here with M, and I put K down here with P,
What
and
was
then
So we don't
KH,
Pythagorean theorem at
right?
all.
So H would be out here, and then this would extend down, and that would be purple also.
What was
And
the
this is congruent to this, and we have these angles and
But the thing is that we don't know
So I didn't put this
those.
up here.
Cause like
crap. We don't know this length and we don't know this length. So
Oh,
what
the
if
other lengths.
No, something about RHL though that
Mr. Hudson.
someone.
Don't we know PN though? From
No,
Mr.
we don't.
Hudson.
Pythagorean theorem.
If you, yeah, if you
Yeah,
did the
but
Pythagorean theorem, then you have the third side be the same.
I'm trying to take a different route.
Oh,
I've
okay.
heard you guys. It's not like I'm deaf. This triangle. Just stick with me. Watch what I'm doing. KGH, right? I wonder if that'll stick with it.
You gonna try and turn it?
Wait, what was the RHL thing again?
If it's a right triangle and you have a hypotenuse and a leg, you can
Okay.
prove congruence.
Well
But we
then,
do have
yeah. Well, we can also say that. So like,
but we do have another one.
or I could say.
Oh
If
yeah.
I rotate this triangle around,
It's the
Wait, I think you have
thing with the like 36. Wait.
not necessarily. What did we just do at the beginning of the lesson?
Bisector.
Wait.
What?
P here would be the midpoint.
Yes.
Yeah.
So if we didn't know Pythagorean theorem, well, let's say we were told we couldn't use it.
Wait, but are we allowed?
Am I allowed to do rigid motions to a triangle?
Yes.
Yeah, I can move it and it stays the same. So then I know KG, so like this would be our K, right? G, H.
But if
And
P
if
was
this,
the midpoint,
Then it reflects
Well-
this property.
Well,
but what if they're
you
not?
have the
But we're
limit.
trying to prove that they're congruent, so we don't technically know if they're congruent or not. So what if the distance from K to G isn't the distance from K to M?
but it is, because we were told this.
Oh,
This.
okay.
So
Never mind.
So P then becomes the midpoint, right?
Okay.
And because we have right angles, P's actually a perpendicular bisector. And we just saw that perpendicular bisectors create congruent triangles.
Amazing.
Right? So there are many ways. The whole reason I'm doing this, give me your eyes so I know you hear me. The main reason I'm doing this is to show you if your homework is different than your homework is different than your homework, that's okay. There are multiple ways to get to the final proof like statement. Does that make sense?
Yes.
That you don't like there are always probably always. There are probably always multiple
You
ways
can find some
to do the
pretty
same thing.
obscure ways to do.
Yeah.
So because Pythagorean theorem is a theorem that has been proven and has never been disproven, we can use it as our reason. So another way to do this would be GH squared equals KG squared plus KH squared, And if kg is equal to mp, yeah, we can work it from there. And and congruent to gh, substitution lets us get that third side. And then we could claim side, side, side. Is side, side, side congruent or similar?
Similar. No,
What's
it's congruent, but
Congruent.
Yeah,
angle
angle.
is.
Side, side, side works for congruence.
Angle, angle.
SSS works. AAA is just similar. Preguntas? You got about 10 minutes actually. You got about 10 minutes. Go ahead and dive into the homework.
I didn't finish the homework before.
Why didn't you finish the one before?
Because I didn't have AO today. I only had one question
So
left.
what? You could have did it at home.
That's because I had one question left, so I thought, okay,
If you
I
had
can
it
do it at home. I
social
could just do it in
studies, you
AO,
did
but I didn't know that there was no AO today.
Hey, if you need, especially because I don't think we're using these
Practically done.
in my other classes.
Three classes, I've done one, and I'm
Yo,
starting the second one.
there are shapes templates over here. So if you wanted to help you with sketching out 39, if you want to sketch it out and not just write out the proof, because trust me, it's easier when you draw on the picture. Use a shapes template and just draw a parallelogram and then label it to match what they have.
Is that the first problem of the homework?
Yes. This is the beginning of your homework. It's 39 to 45.
Thank you.
You are welcome.
Oh, you have to copy the whole proof.
Well, it gives you all the statements. All you really have to do is just say all the reasons.
A lot of writing.